Good morning, guys. Hello. Am I audible?
Yes, sir, you are audible.
Okay, fine. Thank you.
Yes.
Okay. As said, from today onwards, we're going to start the session. Clear? Just a second. Fine. Okay. Let the remaining join. Okay. We'll start the session. Who all are actually, joined for the previous session? There is a 16 hours of session for which some students have registered from this lab. So who have done that basic programming? Among you people, there are a few who have joined the session. Okay, Radhika Chaudhary, only one. Fine, no any issues. I will revise the same things. You have already gone through the session, so I'm going to ask some questions for which. So you already done the session, so you please be quiet and let the remaining be answer and let the remaining take the initiative. Okay, fine. From today onwards, we will going to start the continuous session on basics of advanced manufacturing lab. Okay. Before joining that, so this is what exactly the basic programming will be. So it will be covering some 8 different topics for 8 different days, and in that there will be having 2 assignments and only one MCQ question. There will be no any two assessment, only one assessment will be there after this basic programming. Now we're going to start the session with, as said, I'm going to cover each and everything from the starting. So like the from the basics. So what exactly a manufacturing technology, from that I will going to explain you what exactly a robotic technology, advanced robotic technology till that. So I'm going to cover all those topics in this basic programming, in this basic session. Okay. In the first day of session, I'm going to cover what exactly the manufacturing concepts are. So what exactly a manufacturing is, what are the different types of industries, how that will be depending upon the manufacturing process as well as the different aspects. All those things we will going to discuss in today's session. Okay, and these objectives, once I have completed the session, then I will show you, I will explain you all these things whether I have covered or not. Okay, starting with the simple thing, like I already told you, Hindi or English, which one is comfortable? Is it okay if I continue in English? Okay, thank you. Whenever there is
Yes,
a
yes,
need
sure.
of, examples or something, or if you find any difficulties in this English, then I will try to. Okay, fine. We'll start with this one. What exactly a manufacturing technology is? So you are in the third year. I hope you have covered this topic also. So what exactly a manufacturing technology or a production technology means, guys? What is a manufacturing technology or a production technology or a manufacturing process or a production process?
Sir, a process or technology by which we produce anything.
Okay, fine. Any other answers? See, okay, no problem, no worries. I will explain you what exactly manufacturing technology is. Manufacturing technology or manufacturing process, production technology or production process or a manufacturing principle is nothing but simple thing: conversion of raw material into finished goods by the help of a process. That is what exactly a manufacturing technology or a manufacturing process is. Here, see, RM is nothing but a raw material. So we are in for any industry. If at all I'm talking this arrow as an industry, then what is the input of the industry? RM, which means raw material. And what will be the final good, finished goods? That is nothing but output. So how exactly you are going to convert a raw material into output? By means of a process. So that is what exactly a manufacturing technology, manufacturing process. Conversion of raw material into output by using a process is known as manufacturing technology. Clear? This is the basic principle you need to be clear with. Why? Because any type of industry, it may be an automotive, it may be a complete industry 4.0, or it may be an advanced industry, the same thing that will follow is the same thing. So the raw material is finally converting into output by the help of a process. This process is nothing but the industry, complete industry. The setup, the automation, the machines, the conveyors, the robots, all the things will be involved in this process. Okay, that is what exactly a simple manufacturing technology is. Now this one is, what exactly evolution is? The topic name is evolution of missions. A simple question: what is evolution, guys? What is evolution?
The thing which get,
Sorry, can you repeat it?
sir, anything which get refined over time
Okay, anything that is refined over time.
gets
Perfect.
better and better.
Yes.
Sir, sir, adaptation of favorable condition with the change of time.
Yes. Great. Simple thing, upgradation. Simple definition is evolution, nothing but upgradation. So whether it may be time, whether it may be with the technology or nothing but, so which means upgradation from one stage to another stage is nothing but evolution. So here we are going to discuss about evolution of missions, which means how our actual missions will be evaluated. So how the advancements in missions will be coming place. Okay, that we are going to discuss in this one. The first one is here at the start. The just a second, let me on my cursor. Okay, this is the first one. Here we are going to start with CM. What exactly CM is? This is nothing but, I will explain you what exactly the first one is. First one is CM. CM is nothing but conventional missions. Okay, have you heard this word? Conventional missions.
Yes, sir.
So what exactly a conventional mission is? Have you seen any conventional missions? Have you been to college?
Yes,
First
sir.
thing.
Yes, sir.
So you have visited the college, right?
Yes, sir.
So have you been to workshop? Have you seen the workshop?
Yes, sir.
In that there are a lot of missions like lathe missions, milling missions, shaping, boring missions, all the different missions. All those missions are nothing but conventional missions, which means these missions are going to operate by manually. Okay, All the missions which are operated manually are nothing but conventional missions. Manually operated missions are nothing but conventional missions. Best example is, I hope if you have gone through the milling mission, then the mission is like this. Okay, this will be the mission, and there will be having a tool, and there will be having a bed. If at all you want to move this bed, then see, it is going to move in x as well as y direction. Okay, and the tool is going to move in z direction. If at all you want to move the bed in the horizontal as well as lateral direction, then there will be having some levers, flywheels. Okay, here there will be having a lever, and here there will be having a lever. So if you try to rotate this, what will be happen, this carriage, this bed will going to move in x direction. If you are going to rotate this one, then it will going to move in y direction, plus y to minus y. Same with the tool also. If you want to move the tool upward and downward direction, then there will be having a lever here. So if you are moving that, then automatically the tool will be coming downward as well as upward direction. Here for moving the machine, you are using manual levers, manual movement. This is called as a conventional. Same with the lathe. So this is how exactly the lathe machine will be, a basic lathe machine. Here there will be having a turret in which your part will be holded, your workpiece will be holded, and there will be having a slideways in that carriage will be mounted. In that carriage, so we are going to fix our tool. Okay, if at all you want to move the carriage in this direction, then there will be having a lever here. So if you rotate this one, automatically the carriage will be mounted on the slideways, that will move in the plus or minus x direction. Same thing. So if you want to move the tool towards the workpiece, then there will be having a z. If at all you want to move that plus and minus, there will be having a lever here. So if you rotate that, automatically the carriage that will be mounted, that will going to move in this direction. Okay, so
एक्सक्यूज मी सर।
yes.
सर अभी बीच में आपकी आवाज वगैरह ब्रेक हो रही थी, आप एक बार दोबारा एक्सप्लेन करेंगे इसको?
हाँ ठीक है, नो प्रॉब्लम, आई विल एक्सप्लेन यू. Okay, lathe mission इस तरह होता है. Okay, so if you have seen the lathe mission, then there will be having a carriage, I mean a turret will be there. In the turret, your workpiece is going to mount like this. So we are going to fix our workpiece here, and there will be having a tool carriage. There are slideways that are mounted on the mission, and based upon the mount ways, the carriage will be fixed. In that carriage, we are going to fix our tool. Okay, the tool is going to fix like this. So this is what exactly our tool will be. Now if at all I want to do the operation, so for which the tool is going to from this location to this location, this is what exactly I want to remove the material. For this movement, definitely there is a wheel here. Okay, there is a flywheel or there is a lever will be there. If at all I am going to rotate that, then my tool, I mean my carriage will be moving from plus or minus x direction, which means here, here. If at all my tool need to go towards the part, I mean I want to remove the material, I want to give a feed to the this one, then there will be having a lever that is fixed on this carriage. When I rotate this type of wheel, then automatically the carriage will be moving in plus or minus z direction. Okay, now all these missions are operated manually. Okay, so we are going to operate manually, then only the machine is going to move from one direction to another direction, all the things. Otherwise the machine is static. The machine won't I mean respond on its own. It doesn't have any artificial intelligence or any programming or any sensor things to move the tool from one direction to another direction, or to move the carriage in this direction. Okay, that is why we are going to use a manual levers. So all the type of missions that are using manual program or manual operation is nothing but conventional missions. Clear?
Yes, sir.
Okay, now what are the advantages of conventional missions? I hope you have seen the missions now. So okay, let's not talk about the advantages, let's talk about the disadvantages. So what are the disadvantages with this conventional missions?
Precision.
Okay, precision.
Time consuming.
Time consuming. Okay, any other than that? Main drawback or main disadvantage
Required
of,
operator.
okay, skill operator. Main disadvantage of these conventional missions is repeatability. Have you heard this word, repeatability? Which means, see, I want to operate this type of part. exact dimensions and everything. In the first part, maybe I have achieved this one. So can I achieve the same part for 100 number of pieces if it is a conventional? Is it possible to get 100 pieces with same dimension, same microns, everything? Is it possible?
No, sir. No, sir.
What will
No,
be
sir.
happen in continuous repetitions, in continuous runs? Maybe a slight deviation will going to happen. Maybe instead of this one, maybe there will be having slight error here, there will be having some surface finish here, there will be having some depth of cut, a higher depth of cut here, there will be having some material storage here. Like there will be having, for every part there will be having some repeatability error. That is why one of the major disadvantage is repeatability. We are not going to manufacture same type of production, I mean same type of part for n number of workpieces. That is the main disadvantage of conventional missions. Other than that, there will be, as you said, precision, accuracy, human effort. These are the different things we will be having the disadvantages. But first one is, main thing is repeatability. We can't produce same type of output for n number of products. That is the first disadvantage of these conventional missions. By considering all these things, again there will be having an upgradation or improvement. That is nothing but NCM. Have you heard this one? This is nothing but CM is same, conventional mission. N is nothing but numerical control mission, numerical conventional mission, NCM. Now what is this NCM? Numerical control missions. Have you heard this one? I hope you are done with production technology subject. Right? Mission tools, mission technology subject. In that there will be having this one. NCM is nothing but numerical control mission or numerical conventional mission, whatever it may be, it is correct. Which means I will give you example so that you will be having a clear idea. The best example is our DVD writer. So what will happen in a DVD writer? So this is my DVD writer. What is the input for this DVD writer? Okay, it will be having power, it will be having everything.
Yes.
Okay, so now I need to produce a disk. Okay, I have given a disk. Now what will be happened after that? So it will be injected inside it. So then automatically, if it is a movie or if it is a songs based upon the thing which we have rated here, automatically the DVD player will do that one. Now how this will be happened? How the complete movie will be stored on this disk, or how the data will be stored on the disk? How is it possible? Okay, this is the best example for numerical control missions or conventional numerical control missions. Clear? Same mission is same. So here I am not talking about the tape recorder. Here we're again coming into the actual thing. So CM is nothing but conventional mission. I am having a mission. This is my milling mission. Okay, and there is a tool here that is posting downwards, and there is a bench. I mean there is a bed here. Now for this same mission, I want to operate this mission by using some codes. Okay, which means some X code or Y code, some part programming, some TCM, some tool programming, TPM, like different programmings will be there. Now I want to use that programming. Now how to give that programming? So I have defined some programming. I have prepared some code. Now I have to define this code to this mission. How is it possible? Initially, they have used a controller. That controller is supposed to decode the programming which we have written. Here, if at all writing x, y, z, plus or minus values. So I have given like this. Now there should be some controller that will read the program which I have defined. So this is the controller. Okay. Now where to write this programming? So do I need to write a programming on a paper or a directly mission? For that, there will be using some tape, just like our tape recorders. In the tape recorders, there will be having some cassettes. In that cassette, there will be having some polythene sheet or a plastic sheet in which our a song will be, I mean, rated like this. Like, so we are going to define our program in a tape, okay, in a punched manner. So we are going to define our programming in this one, and I am going to give it to the controller. Then based upon the program which I have written here, the controller will decode it and give the instructions to the machine. That is nothing but numerical control mission. Okay, here the advantage is nothing but the programming will be easier, higher complex part can also be done. But disadvantage is, whenever there is a modification, if at all I want to remove this one and I want to add some square block here, then it is not possible here, for which I have to start a new tape. I have to use a new tape to prepare that one. So that is the main disadvantage in this numerical conventional mission, which means creating a programming easy and running is easy, but modification is a difficult in this numerical conventional mission. Okay, that is the second thing. Clear? Now, by considering that, again considering all those things, the advancement comes into CNCM, which means nothing but CNC missions. I hope you know the full form of CNC missions, right?
Yes, sir.
Now you tell me what exactly a CNC mission is.
So computer numeric control machines, the machines which uses computers.
Okay.
The computers have code which help them to run the machines.
Okay, clear. See, here the principle of the mission is not changing. See, conventional mission, conventional mission. The mission, I mean, this is a milling mission, and the bed is moving in X direction only, in this Y direction only, and the tool is moving in Z direction only. The principle is not at all changing in all these evolutions. What exactly changing here? The way we are operating a mission is changing. Okay, initially we are going to operate the conventional missions by using manually. After that, there will be having some advancements. With that advancements, there will be having some punch tapes, and by considering all the disadvantages, they have invented these CNC missions. This CNC mission is nothing but computer numerical control missions, where the mission is integrated with a control system which is a replica of a computer. That is why we'll call it as a computer numerical control. So this control system is having almost a computer, so which we, by using this computer, we can control the complete control CNC mission, and we can define the program. Whenever there is a need, we can modify also. That is why it is a most advanced one when compared to these two one. So in this CNC mission, again, as compared with NCM, there will be having a programming part. That programming is nothing but part programming. I hope you know this one, part programming. In that, there will be having some G codes as well as M codes, movement codes as well as miscellaneous codes, preparatory as well as miscellaneous codes. By using these two, we can directly control the mission. All the G codes are used for the mission movement, which means X movement, Y movement, depth of cut, all those things will be given on this Z preparatory function. Whereas miscellaneous M is nothing but operating a mission. So how to operate a mission? To start a program, to stop a program, to run the coolant on, to run the other things on, to run the camera on or off, to move the tool at what direction, all those things will be given by using these miscellaneous commands. By using these two, we can give any type of, we can prepare any type of programming, I mean any type of program for this CNC mission. So irrespective of the complexity, irrespective of the easiness, we can define any type of program. Again, the main advantage of the CNC mission is, even if it is having 1,000 parts, we can maintain the repeatability, we can maintain the precision, we can maintain the accuracy. So if a part is having this much of error, so we can get that error in 1,000 parts, we can get that error in 10,000 parts also. That is what exactly a repeatability in this CNC mission is. So the program which we have defined, that will continue for the number of repetitions we have done. All we need to do is we need to check the tool, how exactly the tool is. So what will be the tool factor, what is the wear of the tool, all the things we need to check. Other than that, the part will be produced same. The first part will be, say it should be a replica for the 1,000 part also. Both will be almost, both will be similar, not almost, it will be completely similar to each other. That is the main advantage of this CNC mission. Now what is the disadvantage of the CNC mission? Okay, I have explained you all the advantages. Now you try to explain me what exactly the disadvantage of this one, D. Now what are the disadvantages of CNC missions?
Sir, skilled people are required.
Yes, skilled people are required. Great. Next.
Sir, manual observation is required.
Sorry.
Sir, manual observation.
Okay, manual observation, inspection. Fine. That's it. There are no any disadvantages for this one. Main disadvantage is we need a skilled labor. So if at all I want to programming this type of part in a milling machine, then definitely there should be a skilled person to define this programming. Otherwise, what will be happen? We can't define this. So skilled person is definitely needed. Second one is inspection. So we need to inspect at regular intervals. That if it is a first part, then we need to inspect at each and every corner. First we need to inspect here, 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 we need to inspect at each and every checks. Why? Because we need to check whether the part which we are going to produce will be matching our dimensions or not, will be matching the perfect will be the given dimensions given drawing or not. So whether the surface finish is maintaining or not, all the things we need to check for this one. So there are very limited disadvantages for this CNC mission. Okay, this is the evolution of missions, where the principle of mission is not changing, only the way we are operating missions is changing from the time, cycle of time. Okay, this is a missions. Now while coming into next one, that is nothing but this one. Okay, this is for missions. As said, this is for missions, and these three is for process. Okay, these three is for process. Now let me erase these things. Okay, this is for mission and this is for process. Now what is this DNC? Have you heard this word DNC?
Yes, sir.
What exactly is it?
Sir, direct numerical control.
Control.
Direct numerical control. I hope you know this one. So for as said, every CNC mission should having a computer to operate it or to control it. Okay, let us take an example. I am having a plant, I am having an industry in which I am using some 60 number of CNC missions. So 60 CNC missions, how many pieces I need to have? Now I am having 60 CNC missions. So how many computers do I need to have to operate all these things? Definitely 60 PCs, individual PCs to operate each and every mission. Now, if my mission is having, I mean, if my industry is having 100, then I need to have some 100. So now what will be happen? Definitely they need to have some mission operators to control this one. At the same time, there will be having some computer operators also to need to operate this one. But again, we need to have store data to control all these things. By considering all these things, they have advanced, I mean, they have done some innovations, they have done some modifications, and they have introduced this DNC. That is nothing but direct numerical control, which means all these 100 computer missions can operate by using a single computer. That is nothing but server or a master computer. Okay, instead of using 100 PCs, they are using only one computer, one PC or one system for controlling all these 100 CNC missions. This system is nothing but DNC. Okay, direct numerical control, where we are using a master computer or a master storage to control or to to use all the CNC missions. Now what will be happen? So I'm having one master computer and there will be having 100 CNC missions. Now by using this computer, if at all I want to operate 59th computer, then directly if the mission is on, I can give a command for this 59th mission by using this master computer, and there is an operator over there. Directly operator can do that part. If at all I want to use some 60th program, directly by using this computer I can give the, I mean, I can load the program directly onto the 60th mission. Same, each and every mission is having, if at all, 1000 programs stored in it, so I can store that data also. In 59th mission there will be having some 100 programs. Out of 100 programs I want to use again 59th program itself, so I can directly use that one. By using the storage I can run this one. So this will be act as a storage master computer. If in this computer there will be having, I mean, there will be again having a controller in it. So if the operator try to change something, if he found something and he have modified the program, and that modification can also be, if at all he want to save, that can also be saved here, which means this DNC give the program, at the same time it will collect the feedback also. That is what exactly this DNC is. Clear? Direct numerical control. Okay, this is for improvement of the process. We will be using most advanced machines in the industry. Now I want to improvise the process so that I will be getting more production. For that process they have used this direct numerical control.
Sir,
Yes.
sir, if the objective of every computer, suppose there is 100 computers controlled by one master computer,
Okay.
and if objective of every computer is different, so how it can means command
Okay.
different programs to different computers?
See here, this, I mean, a CNC machine is there and a computer is there. This computer is only for creating the programming as well as modifying the programming. For this purpose only they are using a computer in a CNC machine. This is the main objective of this computer for every CNC machine. Now they have integrated this number of missions by using a simple master computer. This master computer is having some TBs of storage, and it will be having some greater OS and everything. So what will be happen? This much TBs of data that can be stored directly here, by using a different programming. I mean, they will be having some softwares that can control the CNC missions also. By using those, we can directly control any type of CNC mission. If there will be having I mean CNC lathe missions will be there. If there will be having 10 CNC milling missions is there. If there will be having some 20 CNC injection molding missions are there. There are different missions, but what will be happened? The controlling will be same. So here, if at all I want to operate a lathe mission, then there will be having separate software for all these lathes. By using this software, I can directly control these 5 CNC missions by using this one. Similarly, with this rest, that is how exactly this master computer will be stored. Okay, so if there is I mean, if at all the computer or the company don't want to use this DNC, then no problem, they can use an individual computer also. But to improvise the process, they are going to use this master computer to store the data at a single place, so that a single operator or a single master programmer can directly sit here and he can operate all the missions by using a this DNC. Now what will be happen? Just assume there will be having 100 CNC machines and 100 PCs will be there. So for operating a CNC machine, definitely company needs an operator, CNC operator. At the same time, if at all 100 machines will be needed, some programming person is also be needed. So together there is a need of 200 persons to operate a CNC machine, at the same time to prepare a programmer. So to overcome this one, they have created a DNC. In this DNC, there will be having some 10 to 12% for each and every for every portfolio. There will be having some person. If the program is from this section, he will going to manufacture that one. He will going to modify this one. This is how exactly the company perspective. This will be advancement. Clear?
Yes, sir.
Okay, that is nothing but DNC. Again, after the DNC, see, till now the missions were completely automized. I mean, the missions are completely evaluated, upgraded. Now after that, we have used some DNC with which my production is somewhat increased. By using CNC missions, I am getting some 70% efficiency. Let us assume. Okay, by using CNC mission. After that, I have utilized this DNC. By using this DNC, maybe it was increased to some 75%. Let us assume. Now after that, there will be a again advancement, that is nothing but A is nothing but automation. What is automation? A is nothing but automation. How this automation comes into process improvisation? Comes in process improvisation. What exactly role of automation in industry? How it will increase my efficiency from 75 to 80? Any idea?
Removal of human efforts. So if we remove human efforts, we means uh, cost price decreases.
Okay. See, what you are saying is correct, but in industry perspective, we can't say that a removal of human errors. So for which there will be having a certain name that is known as improvising the material handling. Okay. Automation is nothing but material handling. Let us say this is a mission and this is a mission. Mission A as well as mission B. Is it visible?
No, sir.
Now
Yes, sir.
there is a
Now,
mission
now,
A, there is a mission B. Now this mission output, I mean this mission output, A mission output need to enter into B. Okay, output is nothing but input of B. Clear? Now these two missions will be having some 100 meters apart. If the mission is continuous, if the production is continuous, which means for every day there will be having some 1,000 parts that need to be manufactured. Now what will happen to my production if I am using some manual operation here? So which means human come here, he will pick the part, he will move all the distance and he will reach here B station and he will give the part to the B. So if at all I am using a human in this application, how much effort is needed and what will be the efficiency? Just assume it. Now instead of human, now I am using a conveyor belt, a conveyor between A as well as B. Now when compare these two, In which process the efficiency will be increased? Manual or a
Sir,
conveyor one?
So conveyor one.
Why?
conveyors.
Again the question, why?
We can configure the speed of conveyors, sir.
Yes, we can configure the speed of conveyor. At the same time, this conveyor need not need any human effort to lift a part as well as to keep from, I mean, to give it to B. So it is a continuous process. We need to define the programming here. The conveyor don't run, I mean, the conveyor can't run continuously for 24/7. So it is having some programming defined. It is having some sensors. Whenever A is giving part to the conveyor or whenever a part is entering into conveyor, then the conveyor will start moving. Okay, with this what will be happen, it will be moving to this direction, again it will be stopped here, again if a part is coming here it will be doing the same position. This is nothing but material handling. To improvise the material handling we need to use automation. That is nothing but increasing the efficiency of the material handling. That is nothing but automation. Not only in this application, different applications. If there is a AGV is there, automated guided vehicle, I hope you know it. AGV.
Sir, excuse me, sir.
Yes.
Voice break.
Okay, fine.
Sir, can you repeat?
Yes. This is not the, I mean, this is not a limited application. Automation is having a vast application in the industry. Second example is AGV, automated guided vehicle. I hope you know this one, which means there is a small truck is there, this much of size. This truck will comes to a mission, and if there is a human is there, okay, human will bring, I mean, collect the part and he will place here. Like this AGV is having this much of capacity to store all the parts. Once the AGV was full, based upon the program which we have defined, okay, this is, I will call it as a AGV. Based upon the program which we have defined, this AGV, just a second, is my presentation visible or it was stuck?
No, sir, it is visible.
It's visible, sir.
Okay, great. Now this AGV will go to the next station. How this movement was done? How this movement is happening? Because of automation only. I mean, because of, I want to move the material handling rate. I want to increase the material handling rate. Okay. Till the DNC, what we have done? We have improvised the machinery part, and we have upgraded with a computer technology. Okay, with which what will be happened, my mission is perfectly running, at the same time to operate a machine is also increasing. Now what is the second thing that is running in industry? The material movement, one area to second area. So how the material is moving, that is we call it as, technical name is material handling. How the material handling will be increased, then this automation comes into existence. By using this automation, by using the concepts of different automation, I can increase the material handling rate. Okay, so again, what will be happened if I increase the material handling rate? Can I get this 80% now? If at all I increase the material handling?
Yes, sir.
See, previously, this is the first process. I mean, this A to B manual programming, I mean, manual material movement. With this, I am getting 75% of efficiency. Okay. Now, I have improvised it by using a conveyor. That is nothing but second process. So now by using the second process, conveyor from A to B, now can I get this 80% efficiency?
Yes, sir.
Definitely. Why? Because we are using some sort of automated devices, some sort of conveyor, some sort of AGVs for increasing our material handling between station to center station. Because of this, what will be happen? My material movement rate between stations will be increased. Because of material movement rate, what will be happen? I am using some CNC missions, so there won't be any delay. Because of which, I am at least expecting more than 75%. At least I am expecting 80% of efficiency by using this automation. Clear?
Yes, sir.
In industry, for increasing the material handling rate, we need to use, or we are going to use this automation only for material handling. Clear? Now the next one is, again there will be having, the evaluation is not stopped here. By considering some things, they have improvised to this one. They have, upgraded this also. This is nothing but robotics or robotization. Anything is correct. Robotics or robotization. Now you tell me, what is the need of robotics or robotization in industry? Like I already told you, automation. Now you explain me what exactly a robotics, what is the need of robotics for an industry, or what is the need of robotization in an industry to an industry. Previously 70, 75, and 80. We have reached 80 limit by using automation. We have reached 75 by using DNC. We are using 70 by use of CNC. Now,
Sir, to reduce human effort like skilled workers.
to reduce,
Sir,
yes,
sir, to replace humans.
to replace humans. Like I already told you in the previous, previous statement also, there is no any such kind of word, such kind of uh, thought process in industry. Okay, like a human effort to reduce these things. So we can't say this word. Other than that, what will be happened?
So to increase the efficiency of production.
To increase the efficiency of production. How come? How exactly the application will be matched? What are the different, what are the sort of applications where we need to use robots which will increase my efficiency to 85%?
Robots can work without any fatigue.
Yes, without any fatigue. Yes. See, one more thing,
The process will be flexible.
flexible. Yes. In conventional mission, I have explained you one disadvantages. What is that one?
Repeatability. Repeatability.
Okay, repeatability. Now, the same thing that is advantages for this robot. If there is an application, in that application the robot need to do 1,000 number of times. There is a repetition, there is a need of repeatability for 1,000 number of times. Now at that application, what will be happened if human is there?
So there will be errors.
There will be error. So let us take an example of inspection line, okay, or a packing line. What will be happening in packing? In industry, continuously packing, products will be coming, and here there will be having some package persons, here there will be having some 10 persons to do this one. So again, if there is a human, means there is need a lot of things we need to consider, like human factors. There will be having some time intervals, there will be having some breaks, there will be having some sort of errors and everything. So because of which, what will be happened, this complete production cycle depends upon the human itself. Okay, so which means this is a repeatable task, continuous task. If a human is there, what will be happen, for every 8 hours the shift is changing, some other humans will come, and these 8 hours, what will be happen, there will be a delay of 1 minute, there will be having some sort of um, miscommunication, like that there will be having some things. So if at all in this application, instead of using 10 different humans, I am using a robot or 10 different robots. Now what will be happen? Do I need to give 8 hours break in between
No, sir.
shifts? So it is a repeatable task, continuous task. Whenever there is a continuous as well as a repeatable task is there, at that applications we can use these robots. So because of this, what will be happen? It will increase my efficiency. So why? Because it don't need, as said, it don't need any fatigue, it don't need any, delays, it don't need any rest, it don't need any some unconditional losses. So it will, based upon the program which it was defined, so it will do the operation. Not only packing, if at all we are talking about a welding, now what will be happen? There will be having a two plates that need to be welded continuously. This plate is having length of 10 meters, 10 meters and a 10 meters. I need to do the weld part here. So if a human is there, he can't do the weld continuously for the 10 meters, right? Have you done the welding part? Have you practiced
Yes,
welding in
sir.
workshop?
Yes, sir.
So in which, what will be happen, you are going to weld a small plates like this, okay, having a dimension of 5 centimeters or hardly 10 centimeters, right? If at all I'm going to weld that plates, 5 centimeter plate or 10 centimeter plate, it will take some 5 to 10 minutes for me. So now what will be happened, if the length of the plate is having 1 meter, just assume how much time it will be taking at the same time. So whether the operator he is able or capable to do the part continuously. Now you give the
No, sir.
reason. There is a welder here and he want to do this part, he want to do a welding for this 1 meter part. So now is he able to do that one?
No, sir.
Okay, so maybe after some 20 centimeters or 50 centimeters he was paused. Okay, he has paused it. Now what will be happen after it? Till this part he has done the welding. Now we need to start from this point. Now what will be happen at this point if we pause? I hope you have seen the welding, right? In this what will be happened if let me erase everything. So if this is a part and this is a part, this need to be welded continuously. If I weld continuously, a perfect weld will be formed. If I welded up to this extent and I was stopped, if at all I started again at this point, what will be happened? There will be having a material loggage will be there, cloggage will be there. Lot of material will be accumulated here. Or sometimes what will be happened? Material removal will also be there. Material loss will also be there at this point. This is a loss for the part. This is not a correct one. So if he starts from the next point, what will be happen? There will be having a small gap between these two parts, which is no way acceptable. Okay. Now that is for a minimum part. Now if it is a 1 meter part, now what will be happen? A human effort is not able to do this one in a continuous way. In these applications, if I place a robot, now what will be happen? Is a need there is a need of giving any delays or giving any pauses, or can I able to run the continuous in a single cycle? In this type of applications, if at all I am using a robot, then directly I can complete this cycle in a single go through. Okay, in a single run. Why? Because robot doesn't have any things. So all we need to do, we need to define the program and we need to make the we need to make the robot movable or a part movable, so that what will be happened whenever the part is started, whenever the program is started, automatically the weld is completely continuously go like this. It will going to halt at this location only, no matter what. Why? Because we have given. So whether the part is there, whether there is no any part, still the robot is going to do the part. Why? Because we have defined the program, so it will do it. Okay, that is the advantage of this robotics. Okay, whenever there is a repeatable task, whenever there is a repeatability is there at that applications, we are going to use robotics for increase our efficiency. Clear?
Yes, sir.
Now by using these robots, can I increase my efficiency? Is it possible to increase my efficiency to 80%?
Yes, sir.
This is the evolution of missions as well as process. Now again there will be no any pause here. After that again there will be having advancement. That advancement is nothing but industry 4.0. With industry 4.0 I can increase my process from 80 to 85%. Okay, we will discuss this industry 4.0 in the later slides. Clear as of now? These are the basics for the software also. Why? Because we are going to use some sort of mission, some sort of conventional mission, some sort of CNC missions, robots, automation, all these things we are going to use in our software. That is why I have explained you all these things. What is the necessity of a conventional mission in industry? What is the role of robot in industry? Why exactly I need to use a robot? Like that is why. Okay, there are some sort of basics that is needed for this software. So clear with the basics? Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now one of the important topic is this one. Okay, pillars of an industry. Now what exactly the name indicates? I'll say pillars, factors, aspects. Now what exactly it defines? For everything, if at all I want to run a fan, if at all I want, run a fan. What is the things I need to run a fan?
Electricity.
Okay, first one is electricity. What is the second thing?
Motor.
No. I'm having a fan with me. Ready-made fan.
Okay.
Okay, there is no need of internal thing.
An on and off switch.
Okay, first one is electricity and second one is on and off switch. Third one is
Regulator.
okay,
Speed.
the on and off regulator here. Both are also similar applications. Okay, now what is the third one? One of the important thing.
सर ऑन और ऑफ करने के लिए जो क्वेश्चन चाहिएगा वो
Sir, place to install the fan.
Yes, that is nothing but mounting. Okay, so what, just assume, so can I hold a fan in my hand and can I run it? Is it possible?
No, sir.
So for which again mounting is also one of the important thing. For a fan, these are the factors, these are the pillars of a fan. Like for industry, there will be need of some factors or aspects or some pillars. That is nothing but this one. Now I will explain each and everything. Now what is the first step? So I am having an industry. Now what is the first thing I need to have in industry? So if at all I am talking about industry. Now what is the first thing I need to have? RM is nothing
Raw
but
material.
yes, RM is nothing but raw material. What is the need of raw material? Can we produce parts without raw material?
No, sir.
No, sir.
That is the first step for industry. For every industry, raw material is the first and important task. Why? Because without raw material, we can't even produce anything. That is why raw material is one of the key aspects or the first pillar of an industry. Now, what is the next one?
Machines.
Yes. Why? Why missions?
to work on
To
raw
tran-
material.
Sorry, there is a. Can you repeat it? What is the need of mission?
To
So
transform
without machine,
material.
Yes. To convert our part into a useful output, we definitely need a mission. Okay, that is why second part is a mission. Now, what is the third one?
Process.
Again, why?
Everything happens in a particular manner.
Okay, fine. For every mission, they need to have some sort of procedure. Okay, for operating a conventional mission, they need to follow some set of procedure. For operating a CNC mission, they need to have some procedure we need to follow. For operating a bottle injection molding, for operating a bending mission, for every mission there will be having some sort of process for which we need to convert. For which help our raw material to convert into output. That is why process also plays a key role. Now, what is this one? What is this fourth one? Okay, P was done. Now, what is the fourth one? T.
Technology, sir.
Technology? No, not exactly.
Time.
Yes. Perfect. T is nothing but time. Why?
Sir, suppose there is a means demand time of this.
Okay. See, I will give you a simple example. Now, I want to start an industry. Okay. In this is the table where I need to. Here I will be using CM, which is nothing but conventional mission. Here I am going to use CNC missions. Now the mission is done. Okay, raw material. So I am having some SS. Okay, SS is my raw material. Same here also, I am having some SS raw material. It was done, it was done. Now I want to manufacture this type of component. Clear? I'm having some sort of procedure. Okay, here there will be having P1, here there will be having P2. Now time, which one I need to pick? I'm having two missions. With this conventional mission also I can produce the same part. With the CNC mission also I can produce the same part. I'm having same raw material, stainless steel. I'm having some sort of P1 processor for operating this conventional mission and P2 processor, P2 process for operating the CNC mission. Now which mission I need to pick?
CNC, sir.
Okay, fine. Here there will be having a time T1 and T2. Now which mission I need to pick?
Sir, second one. So CNC.
How can you say CNC?
Sir,
Just a second, your some voice is not. Hello, am I audible?
If we use CNC, we will get efficient. Uh, errors. Sorry.
Okay.
Means without error, we will get our products and with less time.
Okay, fine. I will give you one more condition. I want to produce only 10 parts. Okay, and same 10 parts. Here, the time that will take to produce a single part is some 10 minutes. Okay. Here, the time that will produce here is 5 minutes. Now, which mission I am going to pick? Sorry, can you repeat it?
CNC, sir.
CNC.
So CNC.
Okay. I'm having a simple question again. Why can't a conventional mission? Why I am not going
Sir,
to choose
because it is
conventional?
taking more time.
Okay, more time. How many products do I need to produce? What is the total number of parts I am going to produce?
10,
10.
sir.
10.
10.
Okay.
10, sir.
So see here, the parts is this one. Okay, this is this one. Now I will explain you the next one. Now what is this C? T is nothing but time we have defined. Now what is the fifth one?
Cost of operation.
Yes, C is nothing but cost. Now C1, C2. Cost for operating a single part is nothing but 100 rupees. Okay, cost for operating 100 each and every part is some 250 rupees. Now which one I am going to pick?
Conventional.
Now what happened previously? You said CNC mission. Now how can you supposed to say again conventional?
So
What
CNC.
CNC? How?
Because we can produce more number of products in less time.
No, I want to produce only the parts. The 10 is fixed one. I want only 10 parts.
Sir, if we need precision.
See, precision, I am getting same sort of precision in both. Okay?
We have to find out efficiency.
Yes, that's what I'm
Sir,
saying. Precision and
we can tell.
accuracy
Sir,
are,
it depends upon the client.
yes. See, precision and accuracy are both on same missions. Okay? The same. Yeah, I'm producing the same type of output, the same type, everything is similar in this conventional as CNC mission in terms of precision as well as accuracy. Now, which one I am going to pick?
Sir, it depends upon the client.
Okay, if at all
Sir,
if at all I am the client, I was said it's up to you. I have given the freeness to the industry itself.
Sir, profit may be like
So it depends upon the demand.
See, industry will always depends upon these separate categories. Like as you said, demand. That is nothing but number of products we are going to manufacture. How many parts we are going to manufacture. If it is a 10 parts, I'll say okay. It's in my view. I'll definitely go with this one. Why? Because there will be having a limited number of parts, and it is only taking 10 minutes of time. I'm getting same precision accuracy by using this one, and it is taking 100 rupees only. The cost is also limited, so I am going to do this by using conventional missions, in my view. Now, if the number of parts is more than this one, if at all the parts is some 1000, then definitely I will go for this one. Clear? Now, what will be happened if the parts is more, than automatically I need to follow the repeatability. I need to follow the thing. I need to follow the output. Then at that point of time, definitely I will go for this one. Okay, based upon the demand, based upon the thing which we are going to consider is the number of parts we are going to manufacture. So based upon that only, which mission we are going to use, whether a conventional mission or a CNC mission, that will be depends upon. At the same time, we need to check the time also. So if by using a conventional mission, it is taking only 1 minute of time. Okay, now which one you will pick? So previously my number of parts I am going to produce is 10 only. Here 10 and here also 10. In a conventional machine, it will take only 1 minute, whereas in CNC machine, it is taking 5 minutes. The cost for operating conventional machine is 100 rupees, and cost for operating this CNC machine is 250 rupees. Now, which one you will pick? Now, in this application, which one you will pick?
Conventional machine.
Conventional machine.
See, okay, I hope you understand what exactly the things that will define the industry. So, first thing is a number of parts which you are going to manufacture. At the same time, how much time it will be consuming. Third part is how much cost it will be involving. After that, we need to go for the material or all the other things. Okay. Now, the last thing. What is this one? Sixth important aspect of an industry. What is this H? Handling. Now, what exactly you mean by handling? Okay, here I will
Hazards.
hazards. No, see, I'll explain. There are conventional mission and CNC mission. Who is going to operate this conventional mission?
Humans.
Which is nothing but
Humans.
human. Final aspect. Without human, can we do any of these things? Even the industry is automated, completely automated, then what will be happen? Even that automation needs a programmer to define that. Okay, that is why human plays a key role. Human is also one of the important aspect of an industry. Now here see, in conventional mission, the same application, here it is also taking some 5 minutes of time. Here it is also taking 5 minutes of time. Okay, here there is having a human H1, and here there is also an H1. In this H1 and H2, H1 is charging 1000 rupees per hour, and H2 is charging 5000 rupees per hour. Now what happened? So this is also a factor for industry. How many humans we have to hire? How many persons we need to hire? So whether whether the number of humans which you are going to hire is able to do the process or not. So if at all I'm having 100 CNC missions, do I need 100 CNC operators, or can I operate it by using 10? Like that, can I need to use that perspective also. That is why these are the, we call it as a important aspects of an industry. Raw material, raw material, missions, process, time, cost, human. These are all interlinked with each other. Okay, clear with this one?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
in the software which you are going to use, we are going to use these 6 aspects. We are going to use the raw material, we are going to use the missions, we are going to use the process, we are going to use the time, we are going to calculate the cost also. At the same time, we are going to involve some humans also for involving a product, for involving or creating an industry. These are the important aspects of an industry. Okay, now I hope you know this one. PLM, product life cycle management. Have you seen this one, guys? Have you seen this one so far?
No, sir.
Okay, fine.
No, sir.
I'll explain you from the starting then. PLM is nothing but product life cycle management, which means for every product there is a starting step as well as ending step. This between stage is called as a life. So how the product is starting, and finally how it is reaching its condition, final condition, at the same time how it is ending its life, and how it is recyclable. This is called as a product life cycle management. Okay, see here. In this product life cycle management, there are two types. This one is a simple product life cycle management, where we are going to learn this in the textbooks. This is a typical or a industrial PLM, where we see this in the industry only. In industry perspective, this is the PLM. In academic perspective, this is called as a PLM. We call it as a product life cycle management. Okay, here the first one is DE. This is nothing but, okay, I will explain you. 1, 2, 3, 4, and 5. First one is DE, is nothing but design. Okay, every product starts with a design. If at all I want to manufacture a fan, or if at all I want to manufacture a phone, what is the first thing I need to do is design. How the design, how exactly it will be seen in a virtual world. Okay, how exactly it will be looking after manufacturing, that can be directly replicated in this with this design. Okay, that is the first part. After that, it will be entering into M, that is nothing but manufacturing phase, where we are going to manufacture the design part. So if at all I want to manufacture, I need some 1,000 parts, I will manufacture here. Okay. After that, it is nothing but DI, is nothing but distribution. All my parts is going to distribute. I have prepared some 1,000 number of components in an industry. Now what I need to do, I need to distribute it to the distributors or some, I mean shops, so that the part will be entering into market. That is called as a distribution. After that, it will be nothing but C, is nothing but consumers or customers. I will say consumers. So what will be happen? This part will be, of course, it will be reaching to the consumers, final consumers or customers for the final application. Where if it is a pen, then the customers will buy the pen and they will use it. The next one is, final one is EOL, which means end of life, which means how exactly we need to end its life. Okay, that is known as end of life. For some products, if you identify some products, then there will be having these three arrows. It will be like this in green direction, which is called as a recyclable, which means the product can be recycled. Okay. I will give you a simple example. I hope you use this pen, 3 rupees pen or 5 rupees pen, use and throw pen. Okay, what will be happen with this one? So there will be having some sort of ink will be there. Once it was done, then automatically will it, is it possible to change the refill, or is there any refill inside it?
No, sir.
No, sir.
So once
No,
the
sir.
ink is done, what we will doing, we are going to throw it or something, we are going to dispose it. That is end of life. But in company perspective, it is not I mean exact end. In company perspective, again they will collect the pens and they will recycle. I mean they will remove the nib and they will, it is a plastic only. They will recycle it and they will do again some sort of pressure and again they will try to produce it. This is the company perspective end of life. Let us take an example of glass. Now we are using some sort of glass equipments. Once it was broke, what will be happen? We'll simply throw it in the dustbin or we simply make it dispose. But in a perspective, in company's perspective, all be what will be happened if a glass was broken, or if some dispute happened with the glass, automatically again they will recycle it. I mean they will remelt it and they will try to produce a new glass with that one. That is for every for every part which you are going to manufacture, there will be having end of life. That is defined from the industry itself. This is called as a simple PLM or a academic PLM. Okay. Now I will erase this one and I will explain you this one. This will call as a typical or industrial PLM. Like I already told you, all the PLM starts with, yes, any doubt? Clear?
सर
Yes.
सर एक बार इसको दोबारा समझाना प्रोडक्ट लाइफ साइकिल मैनेजमेंट को
नो वरीज। सी मैंने फिर ये इंडस्ट्रियल पीएलएम मैंने आपको एक्सप्लेन करता हूँ, तो आपको ये आपको इजीली एक्सप्लेन आई मीन समझाएगा. आई मीन यू विल बी गेटिंग इजियर विद दिस वन एंड आई विल अगेन एक्सप्लेन यू दैट आल्सो. ओके. सी दिस इज ए इंडस्ट्रियल पीएलएम. इंडस्ट्रियल पीएलएम में क्या होता है कि सॉरी, so what will exactly happen in this industrial PLM is, give an example. What type of product we are going to discuss now? Any word, anything. We'll discuss about that. Any references? Any word?
Sir, a pen.
Pen. We have done the pen. Other than that?
Mobile phones.
Okay, mobile. Let us take an example of mobile. There will be having a lot of mobiles in the market. Now, as a newer into the market, I am going to produce a new product that will be like a X or Y phone. XY phone. The product name is XY phone. Now, what is the first step of my phone? What is the initial stage? What is the initial step of that one?
Design.
Design, sir.
Before design, there will be having something.
Idea.
Yes. I is nothing but idea. Where we are going to start here. I want to start some XY mobile. Okay. This XY mobile. So I am having some sort of idea or innovation with me that my XY mobile will be completely different from the others. It should be having some sort of those things. I need to have some assumptions. Okay. That is my first step, idea or innovation. After that, the second phase is DES, which is nothing but, what is this one? I am having an idea with me. I want to showcase it to some customers or some industry persons to manufacture it. How exactly I need to show them?
Design.
Okay, second phase is design. Clear? First one is idea. Every product starts with an idea. After the idea was done, then we are going to showcase that. I mean, we are going to give skeleton to that idea. I want to produce some XY phone in a circular way or in a spherical manner or in a circle. I mean, simple disc shape. Now all the mobiles are in rectangular shape. Now I want to produce a circular phone in a disc manner. So I have an idea. So I want to replicate it. So I'm using some sort of design software to create that one. That is nothing but in design phase I have created a circular phone, a design phone. Now, what is the next step?
Development.
Yes, DEV is nothing but development. Now, what exactly we are going to do this in the development phase? Okay, in development phase, we are going to manufacture it. I mean, from design, there is having it this one. So, if at all I am going to manufacture this product by using a CNC machine or something, now what are the sort of things I need to consider for manufacturing it? How exactly I am going to improvise it? So how I am going to convert into a virtual manufacturing file? Like for preparing a manufacturing part, what are the different stages I need to consider? That is nothing but a development phase. So I want to manufacture this type of phone. I'm having this type of design with me. So I want to manufacture this one. So for manufacturing this type of part, what are the necessary documents I need to have? What are the necessary facilities I need to follow? That is nothing but development phase. Okay. I'm having now. What is this PT then?
Prototype.
Yes, correct. Now, what exactly prototype is?
A replica of original product where you might have another ideas to develop.
Yes, a replica of the original product. See, what exactly we are going to manufacture is this type of circular phone I am going to manufacture is. I have prepared some sort of development documents. Once those two are done, I am going to manufacture this product in a limited number, which means hardly it will be having 10 numbers. That is called as a prototype. We are going to prepare only 10 numbers for this purpose. This is nothing but testing. Okay, test is nothing but testing, where we are going to test our product. So I have prepared 10 type of prototypes, 10 parts. Those 10 parts are for testing purpose, and each and every part will be having separate test. One part will be having a load test, one part will be having a durability test, one part will be having a tension test, one part will be having how exactly it will be fit in hand, that test. How one part will be tested electronically, one part will be tested some design oriented. Like 10 different parts will be going for a 10 different testing phases. Okay, once all my testings will be done, once all my testings are acceptable, then it will be entering into next phase. If some of the tests were failed, what will be happened? I will be having some sort of 10 tests I need to run. So out of 10, my 5 tests were failed for the circular one. Now what I need to do? Do I need to produce? Do I need to go for the production? Again, we need to go back to the initial phase. Where idea. So where exactly it was failed? If it was failed by using a design, the circular design is failing. Maybe at the center it is having a low tensile point or low impact factor will be there. Now at that point, okay, I need to improvise that. Again, I need to go for improving some sort of idea. Again, I will be based upon the improvements, I will go for the modifications in the design development prototype. So this is how exactly it will be run up to test. Okay, up to test we are going to find, improvise our product. So till how much, till at what extent we are going to finalize it? So if my all my testings are correct, up to 10 out of 10 is perfect. 10 out of 9 is also not acceptable. Why? Because in the ninth condition or in the 10th condition, the part is going to fail. At that condition, the customers will go into not going to purchase this one. So the company needs to go on this one 10 by 10. So which means the part need to go through all the tests, 10 out of 10 tests, then only it will be acceptable. Okay, once my testing was done, now I am having all the documents with me, like this part is acceptable for each and every test. Now what is the next step?
Production.
Yes, now I am going to go for the production. Here do I need to produce 10 parts or can I go for the actual number?
Mass production.
Yes, it is a mass production. I want to produce 10,000 parts. Now what is the difference between production and prototype? In both aspects, we are going to manufacture the product. We are going to prepare the product. Now, what is the difference between this production as well as prototype? What is the difference between these two? On what basis we are going to use prototype? On what basis we are going to use production?
Number.
Based upon the parts which are going, if it is in a testing phase, if it is a before testing, then we will call it as a prototype. For testing perspective, we are going to manufacture it is. Okay, if the testing is done, if it is acceptable, then we are going to go for the production. We are going to use the same facility, but testing is the middle factor. If a testing is acceptable, if a testing is done, then we are going to go for the mass production. Okay, this is the mass production. I have prepared some 10,000 components. Now, what is the next one?
Sales.
Okay, I'm having 10,000 parts with me. Now what I need to do? Sales, supply, this is S is nothing but all these things. Sales, supply, all these things to the customers. Okay. Now, what is this one? Now we have supplied,
So,
sales supplied it to the customers or clients. Now the product is with the customers. Now what is this one?
so feedback.
Yes, correct. Yeah, feedback is nothing but a feedback. Now what is the need of feedback? Why is it necessary?
So for upgradation.
To check how successful the product was in the initial market and to go for further developments in the model line.
Yes. First thing is how exactly the product is matching the customer requirements or not. So it is the initial phase. The circular phone is a newer phone into the market. So we are going to collect some feedback whether the design is perfectly, acceptable to the customers or not. For that aspect too, we need to collect the feedback in which there will be having a lot of questionnaires. Some questionnaires will be based upon this model. Some questionnaires are based upon the improvement. Some questionnaires based upon the dislikes as well as likes. All those things. This is called as a feedback section. After that, it will be entering into this section. Now, what is this one? One of the key element or important element in an industry for sustaining the market. PU is nothing but product upgrade, product upgradation. Okay, product upgradation. What exactly it means? See what exactly we are doing in FB feedback. Hello.
So gathering feedback is to ensure that you know the strengths and weaknesses of your product.
Yes. So we are collecting.
Get the plus and minus of our product.
Yes, we are collecting all the pros and cons or the plus or minuses of the product or advantages or disadvantages, likes and dislikes from this product, from the product which you have prepared as well as supplied to the market. After that, by collecting all the negative points, by collecting all the disadvantages, by collecting all the improvement areas, and this product upgradation team or the R&D team, they will try to convert this in the next upgradation. So in the negative, what will be happen? Some are saying that the edges are sharp. So this will be considered, edges will be sharp. Some are saying that the length is, the size, the diameter of the circle is more. So that they will try to produce some smaller circle. These are some of the inputs they will consider. So by considering all the inputs, again it will start here. So by collecting all the inputs, by collecting all the negative impacts or the negative feedbacks, from the feedbacks which they have received, they are going to overcome it. They are going to remove that. They are going to, reduce that one. And once they were reduced, again they will start a new idea with those ideas, and they will start with this one. Okay, this is how exactly a industrial PLM is. Now the second part, after this one, the second part will be released with, this is a circular phone, circular phone. The next part will be released with CP1, CP2, like 1+1, 1+2, Apple 12, 13, 14. This is how the advancements will be in market. Clear?
Yes, sir.
This is called as a industrial PLM. Now in industry, they will follow this type of form. Whereas in academics, they will follow only this one. See, in the academic, what exactly this one is, the first one is a design. Once we need to have a design, then next phase is we are going to go for the manufacturing. So once the manufacturing is done, then we are going to dispatch it. Once the dispatch was done, it will be reaching to all the customers or consumers. And finally, the product is having its own end of life, which means every product is having some end of life. some if the product is a recyclable product, then they can recycle it. If the product is a non-recyclable one, then they will, I mean, somewhere, I mean, they will dispose it. So again, the companies will collect all the disposed material and they will do the recycling part. If it is a recycling part, they will do the recycling part. If it is a non-recyclable part, they will be having some sort of EOL, end of life terms, to dispose it. Like an example, like polythene, what will be happen after using the polythene? We will simply disposing it in the I mean in the dustbins. But in I mean in industry perspective, they will be having some sort of end of life. They will try to again recircle it, they will try to again remelt it, and they will try to reproduce from that polythene, and they will do the remaining, I mean, next process. For every product there will be having some end of life, which is depending upon the industry itself. Okay, this is what exactly a simple PLM as well as a typical PLM is. Clear?
Yes, sir.
Yes, sir.
Yes. Now, one of the important aspect. Okay, requirements for starting up an industry. Guys, do we need a break or shall we continue?
Sir.
Continue, sir.
Continue, sir.
Okay, fine. So now requirements of a starting up industry. I hope clear with this one. So if at all I'm starting an industry, then there will be having some set of things that we need to follow. First one is a concept, second one is a financial assistance, third one is output. What is the need of concept? Okay, I'm asking you a question. What is the need of concept for starting an industry?
So to enter into any new market, you need to have some sort of innovation. For that, you need a concept.
Okay, if at all I don't have any innovation with me, so am I not going to start an industry? Or is it
Sir,
possible?
we should have idea what we are producing and about what our company is.
Okay, like in the previous slide, we are discussing some sort of a cell phone, mobile, circular mobile. So what happened here? The concept is newer. So that what will be happen? The concept is new. If at all I am going to produce same sort of mobile, now this is a existing mobile. Now what will be happen? There will be having again lot of competition, lot of things. So for sustaining the market, we need to maintain some things. Otherwise, what will be happen? This will be a failure in the market. Why? Because this type of phone is already in the market, and they will be having huge competition in the market. To sustain in the market or to get the different things, definitely we need to have some newer concept, so that the customers or the, I mean, the final product will be hot. It should be like a hot cake. It will be ready immediately available in the market, so that the, if it is a newer one, newer design, everything is new, automatically it will be approaching, I mean, the customers will definitely approach the product in reverse manner. That is why we should be having a newer concept in preparing the model, or newer concept in final preparation. It should be having an idea, it should be having the product, whatever it may be, it should be having a different concept when compared to the rest. Okay, that is what exactly concept is, concept of innovation or idea. So whether for preparing a mobile manufacturer, we should have a different concept, or finally we are going to manufacture a mobile which should be different from the others. Like the concept or the component or the final product should be different from the other, then only we will sustain in the market. That is what exactly the concept is. Next one is a financial assistance. Financial assistance is nothing but factors related to capital cost. Now, what is the need of this one? Financial assistance. Why it is required? Why is it required?
Capitalists need to install new technologies, machines, and industry.
Yes. Capital cost is nothing but, if at all I'm having a newer idea with me, but to get that newer idea into actual shape, we definitely need some sort of capital cost with me. Otherwise, what will be happen? My newer concept will cost me some 10 crores or 20 crores, some 100 crores or 1000 crores. I need to have that money so that I can start the start the plant. If at all I'm having only 50 crores, okay, let us take an example. If at all I'm having only 50C, and my concept is definitely asking me to invest some 200 or 250 crores, then only my concept will work. Now what will be happened? Is it possible to start a manufacture plant with this one?
No, sir.
At this time, what will be happened? My concept will be, this will going to dilute. So based upon the 50, because I'm having this much of investment, now what will be happen? Based upon this much, the concept is going to dilute. This is going to completely differ from day to day. Why? Because my investment is low, my capital cost is low. So to consider that final investment. So based upon the concept, based upon the thing, final assistance is also definitely needed. Financial assistance is also needed. Now the next one is output. quality, quantity, and output. Now what is the need? So we haven't started any industry as of now, but still, why exactly the output will plays a key role in starting an industry?
In sales and profits.
Okay, in sales perspective. Okay, other than that,
So because if there is no market for your product, then your industry will fail.
okay, fine. See, okay, agreed with your answers. And one more important thing, I'm using some newer concept in the market, and I'm having all the financial assistance. But if at all I am not meeting the demand, okay, that is the main thing, demand. If at all I'm not meeting the demand, then what will be happen? Automatically, the product may fail. That is what exactly the output defines. So I need to have some idea that at the end of the day or at the end of a year or for every month I need to produce 1,000 number of components. This type of output cycles need to be have in my mind. Then only I will try to invest, I mean, this much of amount on this concept. Okay, I'm investing some 250 crores in this plant, and by end of an year I am producing only 100 number of components. Now what will be happened? Is it acceptable? Just assume
No, sir.
I'm using a innovative concept to prepare this type of phone, and it will cost me some 250 crores, but at the end of an year I am producing only 100 parts. Which is acceptable or not? Which is no way acceptable. This is where the industry going to fail. Okay, so based upon the output also, now if at all I want to use this type of concept, I want to invest this one, then I am assuming that I need to expect at least 10,000 components from an I mean from for an year. This is how exactly the estimation expectations from an output, I mean from a concept will be. That is why these are the three essential things for starting up an industry: concept, financial assistance, and output. With these three things, we can directly create an industry. Now, after these three things, I am using a different concept. I mean, financial assistance. I am preparing a 10,000 number of components per end of the year. Now, how it will be reaching to your customers? How it will be reaching to customers?
By marketing, sir.
Yes, by marketing as well as advertising. So we will be sharing these 10,000 components in the advertising, so that at least it will be entering into the market. That is why customers is not an important factor for starting up an industry. Okay, I have asked you a question in the pre-assessment also. So what are the different things that will be necessary for industry in that concept, financial assistance, output, and a customer? Okay, concept is a crucial, financial assistance is crucial, output is crucial. Once these three were done, once the output is in my hands, then the customers, entering into customers is a different perspective. That perspective will be done by the sales as well as advertising team. They will go into the advertising, they will use some sort of brand ambassadors, they will do all the things to disclose the product to the into the market. Okay, now we are entering into one of the important thing, that is nothing but industry 4.0. In the second slide, I have explained you evaluation of missions. In this, how the missions will be evaluated from CM, NCM, after that CNCM. After that, we will be discussing about process. In that process, how exactly it will be from the DNC, what is the need of automation, what is the need of robotization. And again, there will be having some sort of 4.0. That is nothing but industry 4.0. Any idea on industry 4.0? Fine, no worries. I will explain
No,
you.
sir.
Okay, I will explain you what exactly it is. Industry 4.0. Before starting that, I will explain you what exactly is first industry 1.0, 2.0, 3.0. Then I will come into 4.0. Okay. So these are the four important things. Four industry revolutions. We will call it as a evolutions or industry revolutions. Industry 1.0, which was started in the early 1784, 17th century, where sorry, where we are going to work on these type of mechanisms, different sort of mechanisms. They have started on steam power, they have started on the some waving icons. On all these aspects they have started creating this one. At this time only they have created the steam trains or some sort of steam engines. That is called as a industry 1.0, first stage of industry, first grade of industry. After that, industry 2.0, that is nothing but a mass production, assembly lines, electrical energy, usage of electrical energy. Thus, that will come in the 18th century. These are the essential things that will coming in the second stage of industry. After the mass production is involved, like already, I mean, like in the examples I have told, I need to produce 1000 number of components, and this is the A station and this is B station. Previously what happened, this material handling will be done by humans from one station to another station. This is the main problem in the second stage of industry, second stage of industrial revolution. So now what happened, they have started industry 3.0 to overcome this one, to overcome the material handling between stations. That is industry 3.0. Automation, involvement of computers, and involvement of electronics and sensors for improvising this automation. Complete automation will be depending upon the industry 3.0, where the material handling rate will be increased. Why? Because in industry 2.0 itself the mass production is started. So to increase the production, to increase the efficiency of the mass production, then there is a need of automation. That is nothing but industry 3.0. Now we will be discussing about industry 4.0. Okay, this is industry 4.0. Industry 4.0 is nothing but see, this is the thing. If at all I'm talking about this one, this is a facility. Okay, this is a facility. I mean, this is an industry. If at all I am talking about this as a industry. Okay, now I want to convert it digitally. I hope you know digital is some set of softwares I want to control by use of softwares. Then I am uploading in the internet. INT. This is nothing but industry 4.0. Okay. No worries, I will explain you in clear again. Industry 4.0 is, see, simple definition is integration of manufacturing with digital technology and internet. Okay, that is industry 4.0. In simply what will be happened, we are using different sort of softwares in mobiles, right? So if it is a cam scanner or if it is a Google Drive, what will be happened? So we are using some sort of Gmail or Drive or some sort of cloud, I mean not cloud, some sort of photos, different scan, classroom, different type of Google platforms to conduct different things. That is nothing but applications. We are using some sort of digital things. This is called as a digital applications, and these data we are storing in the internet. Okay, this is one part, using some software, and we are storing that data in the internet. This is some sort of industry 4.0. Now I want to do this thing for an industry. I want to do an industry for industry 4.0. That is nothing but, if there is an industry, I mean a CNC machine is there. Okay, that machine is completely operated by a computer. This is machine and this is computer. If it is a computer is right, then there will be a software is there to operate this machine. Okay, then I'll call this machine is a digitalized. Why? Because this machine can be operated by means of a computer as well as a software. Okay, I'll say this as a digitalized mission. Now I'll store this complete data in internet. This is nothing but 4.0. Clear?
Sir, excuse me, sir.
Yes.
Sir, this upgradation of all industries is same for every manufacturing industry.
Yes, same.
Okay, sir.
Okay, see, whatever the mission we are using it, we are going to use it, I mean we are going to control it by using a digital software or a computer, where we can control the mission by using this one. Once I am using some sort of computer or some sort of software, then that data can be directly stored in the internet. That is nothing but 4.0. See here, integration of manufacturing with digital technology and internet. Here there is a CNC mission, we can use it. If at all I am having a conventional mission, is it possible for industry 4.0? Now I am having a conventional mission. I can't control it by using a software, right? So if at all I want to convert this conventional mission also industry 4.0, then I need to have a complete data in the computer, which means when the mission was purchased, mission nomenclature, mission data. So how much parts are produced, how much time it is required, what are the different parts that are manufacturing, how much time it will take. So what is the drawbacks of the mission? If there is a failure, what is the type of failure that is needed? For every failure, what is the MTTR, mean time to repair? If there is a MTBF is there, how much it will be having? So what will be the accuracy of the mission? How much outputs till now it was consumed, it was prepared? So what are the innovations? What are the tools that is consumed for this mission? What are the sort of different applications that is going to produce? What are the different areas where the mission is improved? So what is the cost of mission? What is the lubrication cost? All the mission nomenclature, all the mission history need to be digitally converted, digitally created, which means by using a dock or by using something. And whenever there is an operation is coming, means tomorrow there is an operation for which I am going to use this conventional machine and I am going to prepare 100 number of components. Now this complete data at first operation, what is the data? Second operation, what is the data? Third operation, what is the data? At each and every operation, what are the different criterias that I need to follow? This complete data need to be digitalized manually, and storing this complete data in the internet is nothing but 4.0. Clear? Or do you need to explain me again?
So once again, please.
Okay. Now I am not talking about any industry. Now directly I am going to talk about a some other thing, so it will be easier for you. If at all I am talking about NIT, okay, NIT KKR. This is the institution. Now I want to upgrade this industry to industry 4.0. Now how can I say, I mean, how can I convert this? How many departments are there? So there will be having, I will creating a complete data in a computer, like departments, DPT, okay, departments. Next, uh, this is for staff departments, student departments. Next, uh, previous data. Previous data is from starting. Maybe it is started in 18th century. Then from the 18th century to till date, what is the complete data? After that, current data. CURRENT. Current data. After that, attendance. Attendance for current data. After that, there will be having exam data. Okay. After that, there will be having a recruitment data. After that, there will be having a part-time staff, regular staff, all the staff data. Then there will be having a vehicle data. Then there will be having a website data. Then there will be having a bank data. Like each and every department that are there in the NIT Kurukshetra, I need to digitalize it, which means I need to collect the data for each and every department. Now again, in the sales department there will be having, I mean, the students department or staff department, there will be having some 15 departments will be there, each and every sub department data. And in this every department there will be having 100 number of staff, each and every staff data. So when he was joined, his date of birth, is all the particulars, everything, all the data with this one. Similarly, we need to create the complete different data for this NIT KKR, which means who has started this one, what is the name, when it was given as an NIT status, so what is the area, location, how much areas it was occurred, like every data need to be collected, and it was digitalized. Digitalized is nothing but we are going to create the data, we are going to segregate the data in a computer or some sort of software or some sort of SAP documents. So we'll going to convert this document in a computer base. Now what happened, I am having a huge data, I am having some TBs of data for this NIT KKR digital data. It has everything from starting, from day 1 to day 10,000. So it is having everything involved in it, or 1 lakh days, everything involved in it. So all the inputs, all the incomes, all the outtakes, everything was there in this one. Now I'm having this much of huge master data. Now where can I supposed to store it for further usage? Maybe I want to, I mean, I have created it, but something suddenly some computer may be corrupted, something going to happen in future for this computer. Now what will be happen, all this data is going to lost. Now I don't want that one. To overcome that one, I am going to store this complete data. This is nothing but a big data. This big data in cloud computing or internet or in cloud storage, where what will be happened, all the data which I have defined here will be stored in a cloud platform, so that Maybe tomorrow this computer is going to fail, or I'm going to use some other laptop for some other usage, or tomorrow I go purchase some other computer where I am going to use this complete data. Then how can I supposed to use? If it is not uploaded in the internet, then it will be difficult for me to copy all the documents in a hard disk or something. Then it will be having a lot of problems, or while copying or while crashing. If it is uploaded in the internet, what will be happen? So all the data will be perfectly saved in the in the cloud platform. Whenever there is a need from this or regulations or examinations, directly I will download this file and I will cross check anything at any point of time. Maybe after 50 years also, someone is going to use this one, this staff department, there is having some renewable energy department. So directly they can download this file, they can go for that the module, and in that they can search each and every aspects in detail. That is the advantage of industry 4.0. So digitalizing the facility, whether it may be a college, whether it may be an industry, whether it may be a library, cinema hall, even a house also. Even if it is just take an example of our house, what will be happened? So when the house was constructed, what is the initial document? So previously from whom we have purchased the house, now how many stories, what is the building, layout mapping of the site, how many stories the building have, now how many rooms it is having, how many windows it is having, how much cost it was involved for preparing that type of house, how much electricity we are consuming every day. So what will be the water bill, what is the municipality bill, like every data we need to collect it, how many persons are living in that house, what exactly he is doing, so when he is coming and when he is going out, so how many vehicles are there in that parking section, what will be the water usage, if there is are any pets, what is the pet usage, like each and every data of that house need to be digitalized. So that what will be happen, so if it is a software, if there will be having some set of softwares, then we can directly upload in the software by using the software itself. Like CNC missions, there will be having some set of softwares, directly with the software we can control the mission. If the mission is not having any software of the, if the house or if the facility is not having any software to collect the data, then we can need to do the manually. So we're collecting all the data manually, which means digitalizing the data. Once the big data is with us, then we are going to upload in the internet or a cloud storage for further usage for the future references. That is nothing but industry 4.0. Clear?
Yes, sir.
Everyone, this is an important topic, that is why I explained you in detail.
Yes, sir.
Yes, sir.
Okay, fine. Now, as I told you, if at all we are not having any software, then this is the way. If at all we will be having software, then no need directly. Why? Because the software itself collecting the data, which means just assume that. Guys, am I audible?
Yes, sir.
Okay. So if at all there is a software, just like the feedback forms, so you are going to, you are going to fill an application form for an industry, or if you are going to create a Instagram account or a Facebook account, what will be happen? All these data will be definitely saved in the some cloud storages. So when you have signed in, when you have signed out, so who are going to operate these accounts, all the big data will be saved with some things. This is how exactly it will be. Now here they will be having one of the important thing, so which means we can directly operate, industry 4.0 is nothing but if there is a mission is there, that mission can be operated by using a computer, at the same time can be operated by a phone also. This is also one of the important thing for this one. Why? Because if the same application is built in this one, like the Google platforms, we can use the same Google Meet in the laptop, in a computer, even in a phone also. Clear? Based upon the application compatibility, we can use it any type of platform. That is what exactly one of the important catch in this one. Okay. At the same time, we can give the comments. At the same time, we can receive the comments from any type sort of device. It may be a phone, it may be a pager, it may be a laptop, it may be a computer, it may be a master server, anything from which we can organize the data, we can control the data. That is what exactly the industry 4.0 is. Clear? Now I will give you a simple example. Let us take a simple example of our daily, what exactly we call it as, I forgot its name, Flipkart, Amazon, all those platforms. What happened in that? So if you want to purchase a product, Okay, what will going to happen over there? So you have found a product and it was very much good looking and everything was done. You are completely going to buy that and you have made the payment also. Now what will be the next stage? Now you explain me in steps. You have done the payment. Now what is the next step?
So the
Delivery.
order is confirmed and then it is transported from the retailer to an Amazon holding facility. Then from there it is out for delivery and it reaches your doorstep.
Okay, is it a step by step procedure or it's a instant procedure?
It's a step-by-step process.
Okay, first we will be receiving a confirmation message from the so and so client whether the product was confirmed or the payment was done. So we have received your order and your product will be soon dispatched. Like that, you will be receiving a first message. After that, after maybe 1 day or 2 days, you will be receiving a product that the product is dispatched from the godown or from the store. You will be receiving a message, and the next message will be the product will be entering into logistics department. It is with some courier, DHL courier or DHDC, like different couriers. It will be with different couriers. After that, so you will be receiving message continuously like your product is at some station, your product is at X place, your product is at Y place, your product is at Z place. Finally, it is when it is reaching your final location, the product is at your location and it is going to deliver today with this so and so person, like that. Okay, even after receiving the product also you will be receiving that product is delivered. Kindly submit your feedback. How this much of data is performing? How when how exactly it was happened? So when you receive the product, instantly after a minute, directly you will be receiving a message that product was delivered. How that the message receiver, the message sender knows that product was delivered? How exactly all these things happened? Hello.
So because all of the data that from the moment you purchased your thing, it is being stored in the cloud and it is being monitored by a person at Amazon.
Yes.
So when it is delivered, then your account is automatically updated and it is updated on the servers that the order has been delivered, and so you get the message.
Yes, perfect. So this is what exactly the answer is. At each and every step, whenever we have done the order, so what happened for the industry and we will be the customer. So at industry perspective, what will be happened? They need to update it each and every perspective. Other than that, what will be happened if the company is not giving the step-by-step procedure updates? Let us take an example of this one also. So if the product has reached some indoor station, after that you are not getting the messages for next 5 days or 6 days, then what will be happen? What you are going to do? The product is starting from somewhere, some West Bengal or Kolkata, and it has reached all the location. Finally it is reaching some Gujarat. Okay, it has reached the main Gujarat, and after that it's supposed to reach at some Gandhi Nagar or some Vadodara. But after the Gujarat section, you are not receiving any sort of messages from the so and so person or from the customer. Then what exactly you need to do? What you will be going to do?
Sir, you raise a query, sir.
Raise a query to whom?
To
To
the
the
service.
support staff.
To the support staff. In that, what you are going to do? What you are going to deliver? Sorry, your voice is not audible. Can you repeat it? What you are going to deliver to the customer care?
In any travel or something.
Okay, fine. So we are going to deliver the statistics. We are going to say that the product is up to Gujarat section. We have received the message. After that, I haven't received any sort of messages. Can you please tell me what exactly the status of my product? It is already more than 5 days or 6 days. Can you please track it for myself? This is like we are going to ask them. Okay, if we are having the data, if the service provider, if the if the industry is not providing the data from day one itself, which means initially they have given the data like the product is dispatched from the godown from that day. So if you haven't received any message, then what will be happen for you? So we don't have any sort of information step by step process, that we don't even expect when the product will come or where exactly the product will be at that time. So if you call the customer care after 10 days, now what exactly you are going to say? Why? Because we don't have any information directly. We'll ask the same question, where exactly my product is. I haven't received any information and I haven't been contacted from the customer for the product. This is what exactly we are going to say, right? That
Yes, sir.
to overcome all those things, that is why what exactly happened is all the industries, all the Amazon, all these things, we have uploaded the data in the industry 4.0. That is nothing but cloud computing, where what will be happen whenever we are purchasing a product, or whenever we are purchasing a product, automatically that your data will be stored in the cloud storage as a customer. So at each and every step, your product statistics will be uploaded in the internet. Like if the product was dispatched from the from the godown, so that data will be stored in the cloud. So automatically automatic message will be shared with you. So when the product is stating at some location, like as I said, West Bengal, so automatically a message will be shared from that godown, from the West Bengal godown. The data will be stored to the cloud. At the same time, the cloud will be sharing that information to you, that the part is entered into this location. After that, it will be reaching some sort of Madhya Pradesh. Then the same thing, the product has reached the Madhya Pradesh station, so you will be receiving that sort of message. At each and every station, the data will be stored in the cloud, so that the cloud is computing the cloud is computing all the data, and it is delivering the what exactly it is needed. So the same will be happened with the customer care also. So if you have called the customer care, then what will be happened, they will going to check the statistics of the product. So where exactly the product on the previous day, so where exactly the product it was last updated, like they are going to check in this basis only. This is what exactly the main advantage of industry 4.0 is. So which means all the data which will stored in the internet, so whenever it is needed, so automatically you can directly retrieve it, or you can control it, or you can reuse it, the data. That is what exactly the one of the main advantage of industry 4.0. Clear?
Yes, sir.
Yes, sir.
Okay, any other examples from your side? No need of 5 minutes break. I'm going to end the session after 5 minutes itself. Okay. As said, there will be having only one more slide, so I'll going to conclude it. Now, can you give me any example on this base? I have given you like all the social media platforms, all these sites, Amazon, all these sites, shopping sites. Those are using Industry 4.0. Other than that, any idea? Any example from your side, which will somewhat amplify this Industry 4.0?
Sir, what about railway system?
Railway system somewhat follow the same thing. Current train inquiry system. Simple thing. Your what exactly those things? Red bus or Ola, Uber, all those things, they will follow the same thing. So whenever there is a need of any cab or cab services, definitely you will on the map. So what will be happen, your location will be directly given to the cloud storage, and the cloud will compute the data, and it will collect the data like wherever, in the in and around drivers in your area, they will collect that information, they will showcase you on the app, so that that is visible on your social, the application. So whenever you are going to pick that application, whenever you are going to book a ride, so automatically the data will be given to the same person, the driver, like in the same manner. So where exactly the driver will be, like you will be receiving a message, this driver has confirmed your order, this OTP is for the confirming your ride. So when you step into the cab survey, when you step into the cab, like you will be receiving your journey was started. So when you reached your destination, again you will be receiving matter, okay, thank you for using the cab services, kindly share your feedback if you are having anything. Like you will be receiving continuous messages. Why? Because this data will also be continuously saved in the internet or cloud storages. This is one of the best example. Clear? So industry 4.0 is not limited to the industry itself. It is a vast area where we can integrate any type of application, where we can convert it for a library, where we can convert it for a bus station, railway station, airport, for anything we can do for this industry 4.0. Clear the concept of industry 4.0?
Yes, sir.
Digitalizing
Yes.
the complete data and integrating
Yes,
it with
sir.
the internet is nothing
Yes,
but
sir.
industry 4.0. Okay, now I have explained you already this industry 4.0 evolution is like there will be having some advantages like customized according to the customer requirements, smart factories with flexible productions, dynamic production according to the demand, use of product as a service, maximize ROC, profitability, flexibility in the work organization. Of course, if you are using industry 4.0 as a benchmark, then automatically what will be happen, all the data, all the documents will be supposed to store in the internet. So if at all I want to increase my profit, or if at all I want to start a new facility, so that I will check the check the cloud storage. So whether this product was previously mapped or not, previously manufactured or not, I will check in the cloud data. If the same product was manufactured 5 years back, then I will directly download that file and I will use that file as a reference file, and I can start the production. That is what exactly happened in this industry 4.0. If the product is completely newer to the market or newer to the manufactured plant also, then I will collect all the data and I'll upload in the internet, so that what will be happened, this product may be used as a reference for in the future. That is one of the advantages of this one. And at each and every step, the data will be stored in the industry 4.0, so that what will be happen, different teams will analyze. If at all someone wants to increase the production, someone wants to do the analysis part on the failures, then directly they will download these documents by using the Google data, cloud data, and they can directly go for the analysis part. That is one of the advancement or a important thing for this industry 4.0. Clear? Any doubt so far in the today's session? Now
No, sir.
we will be discussing objectives. After the complete session, have we discussed this one? Know the various manufacturing technologies. What
Yes,
exactly
sir.
manufacturing technologies is? Next one is evaluation of
Yes, sir.
missions,
Yes, sir.
pillars,
Yes, sir.
PLM
Yes, sir.
Yes, sir.
4.0.
Yes,
Yes,
sir.
Yes,
sir.
sir.
Any doubts or clear with the basics for today's basics?
Clear, sir.
Okay, fine.
Excuse me, sir.
Yes.
Sir, nowadays we are using internet in all startups and all industries.
Hmm.
So can we say that they are industry 4.0?
Yes. Whenever there is a need of a software or digitalized platform to upload the data in a cloud storage, then it will supposed to call as industry 4.0. But for that, they need to allow some sort of automation also. Directly using a simple internet application, we can't say that it is a industry 4.0. For industry 4.0, they should be having some sort of other procedures also, like it should be having some material handling devices. So it should have some automation devices. That automation data need to be collected, the improvements. Directly we can't use a simple mission in a process and we say that industry 4.0. Industry 4.0 is the final advancement. So for that, before we need to follow these type of things in an industry. For an industry, this is the steps. Industry 2.0, it need to work. Industry 3.0, it need to involved. Then only industry 4.0 comes into place. Just assume that there is a running industry is there. In that industry there is no any material handling device. So human is using the material handling. Human is one of the material handling person. Then what will be happen to the production? Even for if you use industry 4.0 also, there is no any increase in the production. So if he is using industry 2.0, 3.0, then industry 4.0 will try to increase his production when compared to the normal one. Okay, it is a step-by-step process for an industry. But for the other organizations, directly by integrating the internet digital technologies, that is the industry 4.0. Clear?
Okay, sir.
Okay. In tomorrow's session, we are going to start the simulation. So like what are the different simulation, what are the simulation means, what exactly simulation will be used. Like in tomorrow's topic, we are going to discuss all these things. Okay. Can you share this PPT? What you will do with this PPT? Anyhow, it is having all the basic data itself. Fine. As I said, this data is a recorded session. So maybe these videos will be going to available with you. I will have a discussion with some persons here. If I will get the nod, and I will share this complete video, and or I will upload this upload in the internet itself, so that you will be having a link, and whenever there is a needed, you can directly use as a reference file. Okay. Clear so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then chalo. Bye bye, guys. Have a great day.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.